Good morning. We're going to get started with this morning's discussion of fire service communications and why they're not working. For most of us in the fire service, fireground communications currently is a very critical topic. We either have systems that aren't maybe working as well for us as we would like, or we have a system that works great, but under the federal guidelines on rebanding and narrowing spectrum, we're going to have to change the systems that we have. And we all have concerns, of course, about how that affects budgets and, most importantly, fireground safety for the individual firefighters. With that in mind, the IFF has put this panel together of experts who I'd like to introduce right now. To my immediate left is Jonathan Moore. Jonathan's the IFF Fire and EMS Operations GIS Department Director. He's been with the IFF since 1996. Holds degrees in emergency medical services and biology. Formerly, he served over 8 years with the City of Concord, New Hampshire as a cross-trained dual-role firefighter and paramedic. As the Director of Fire, EMS Operations and GIS Assessments, Jonathan provides coordination of customized technical assistance for fire-based EMS systems in the U.S. and Canada. Additionally, Jonathan represents all firefighters on the Public Safety Advisory Committee to the Federal Communications Commission. Please welcome Jonathan Moore. Next to Jonathan is Mike Worrell. He's been a member of the Phoenix Fire Department for 25 years. He started his career with the Phoenix Fire Department as a telecommunications technician and became a firefighter in 1993, was promoted to captain in 2001. Mike has worked on the Phoenix Fire Department's transition to a trunked radio system. Mike has researched and written papers on trunked radio systems and their impact on fireground operations. He's also worked with the National Institute of Standards and Technology on in-building radio coverage issues and digital radio testing. Please welcome Mike Worrell. Next to Mike is Joseph Brooks. Joseph has worked with the Boston Fire Department since 1983 in dispatch operations. In 2005, he was assigned to the communications section as a radio supervisor. In 2008, he assisted the IFF with the Voice Radio Communications Guide for the fire service. He's also a member of the Metro Boston Homeland Security Interoperability Committee. Please welcome Joseph. Finally, we have Karen Ray with us today. She's the branch chief for the Department of Homeland Security's Office for Interoperability and Compatibility. The office strengthens interoperable wireless communications and improves effective information sharing by developing tools such as standards, reports, guidelines, and technologies to enhance the overall planning and coordination at all levels of government. DHS has provided funding for the Redmond Symposium for many years, and thanks to Karen's direct help, has also funded the IFF DHS Fire Service Communications Manual. Please welcome Karen Ray. My name's Tim Hill. I'm the president of the Professional Firefighters of Arizona, and I'll be your moderator today. We're going to try to leave you with useful information that you can take home to help solve your communications needs, whether it's design of upcoming systems or talking to your local, state, and federal elected officials about what the needs of firefighters on the ground actually are. And we'll start that with an overview of what's going on today with Jonathan.
All right. Good morning. Tim gave you my introduction this morning. I'm the Director of Fire and EMS and the GIS stuff, but I'm not going to talk about that today. I'm going to talk actually as an end user of radios. We're going to talk briefly or at a high level about the radio problem that exists, and then the very smart people to my left are going to take you down into the details and answer questions at that level. All right, so anybody remember the radio like this? Show of hands. Couple of us, okay, there's some gray in a couple of places. This was one of the first radios I ever sort of laid my hands on. Low band, one frequency, it worked, right? It was a brick, boat anchor, and a radio all in one. How about this one? Did it work? Did it ever fail? No. Okay. This, the back of the PC's car. It's got two multi-line phones. It looks like some sort of an Ethernet and a satellite uplink, downlink, all sorts of patch panels and gadgets. Anyone have one of these in the back of the BC car? Why is that? Do you suppose this works 100% of the time? What happens when it rains? It's done right there. Okay, let's talk very high level intro to Radio 101. Very simple simplex. This is really the basic part of the system. We have 2 fire engines and 4 portable radios. They can all talk to each other. Maybe it's more than one channel, but it's simplex. I talk to you, you talk to me, I can hear you, you can hear me. That's good, right? Likelihood of failure, aside from the batteries, pretty low. A little more complicated, supported simplex, dispatch center, transmit, fireground operations. This is an enhancement to the system where the dispatch has some remote receive antennas. They can hear what you say, you can still talk to everyone else. The signal goes in, the signal comes back out. There's some gadgets in the middle, adding to the likelihood of some failure there. These remote receivers are what we call voters, voters that actually listen to you. Simulcast system, a little bit better, a few more moving parts. So you have fire engines, portable radios, they talk to the tower talks to the control system sends it back out, and I can talk over there. This gets a little more complicated and a little more likely that I'm not going to be able to talk from here to there if something in this system starts to fail. Trunk system. How many of you have trunk systems in place now? How many of you have trunk systems that have failed? Almost all the same hands went up. Not so good. Better? Like an eye test, right? Better, worse, better, worse. P25 is the digital version of the trunk system, or the digital version of audio transmission. It takes your analog, regular audio voice, translates it into digitals, ones and zeros inside the software, and spits it back out. How many of you have P25 digital systems? How many of you have talked to each other sounding like R2-D2? Same number of people. When it does that, wouldn't you prefer to be able to just push the button and just talk to somebody else? Yeah. Is that operable? When I can't talk from here to there without sounding like R2-D2? No, that's what we're talking about, operability, the importance of my radio, my voice getting into your ear when I need it to be there. LTE, long-term evolution. This is high-level engineering material that I'm not going to cover. And there's a whole definition here, but suffice it to say, it's 4th generation radio, radio technology, which comes from the cell phone world, really. How many of you would want to bring a cell phone into the burning building with you and rely on it to get you back out? There's no hands on that one. That's interesting. Okay, so the vote in this room today is no LTE on the fire ground. We'll talk about that. All right, operability, let's talk about that. That is responders talking with responders, companies talking with companies, companies with incident commander with communication center, automatic aid units with common dispatch center. This is the one that I worry about. Responder Mayday with all radios. That's it. That's where it all boils down to for me. You can have a helmet cam and someone can see what you're doing, but if I can't hear you say, come get me, it's not a system that works for me. Interoperability is, can they hear me now? So that's mutual aid units with the dispatch center, on down the list, companies with incident commander, again, all the way to the bottom, responder Mayday with all radios. So when your neighbors come to help, can they talk to you to make business happen? And if they have a problem or you have a problem, can you help each other out in a Mayday situation? That's interoperability. Problems. Why do systems fail? Some systems are not operable to begin with. The poorly designed, poorly executed P25 trunk systems where you can't talk to each other, And we'll talk about what makes that happen sometimes later. That's an operability problem. Some systems aren't interoperable. You can't necessarily take a fire engine from New York City and send it to California to bail them out for some reason and have it actually work. You can't talk to each other. Spectrum is crowded. Everyone has to have a radio, right? That's true, they do. Everyone else seems to need to have a radio too. So everyone's got a radio and everyone wants to talk at the same time and everyone's on a different system. The entire spectrum from A to Z is pretty crowded, resulting in a move to this narrow banding thing, right? A narrower frequency control for your radio, which is great for having more room, not great for the radio itself or making it work in pressure situations. Limited communication surge capacity. How many of you have pressed the little button and got the busy signal? Beep, 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 beep. I'd really like to talk, but everyone's talking. All right, limited communication surge capacity, and that could be your radio within your system or a Katrina where everyone wants to come and talk and there's really only one stick up in the air connected to one wire connected to one radio, okay? Competing proprietary systems. I'm not going to mention brand names, but there are a couple that can't talk to each other. This digital gadget over here can't talk to this digital gadget over here because you have to buy all of this digital gadget to talk, okay? Not a whole lot of competition there, but that's business. I'm talking about when I come to your house to work, when I push this button, can you hear me? Inadequate equipment familiarization. Everybody in this room has played with all of their radios at home and can work them in the dark, right? Show of hands. How many of you can disassemble and reassemble radio parts combined from your company and get one radio that works in the dark, blindfolded? How many of you can take your SCBA off your back, everybody disassembles them, puts them back together, everyone comes out breathing air? Right. They teach you that in rookie school, right? They take all your stuff, put it in the cellar in a pile, don't come out until everybody's breathing air. Nobody ever does that with the radio part. Okay, what happens when my microphone wire burns off and your radio body melts, but I've got one of each? Can you put those together? That's a training experience, right? Lack of communications SOPs. Show of hands, real quick, how many of you have very clear communications SOPs or SOGs that define how radios are used, when they're used, what you say when you're on the radio, what channel you use, and what mutual aid companies are allowed to use when they come? Wow, there's like 13 people that have trunk 800 megahertz P25 systems, but only 3 that have SOPs. Maybe that's why things don't work all the time. All right, some of the problem solvers, and this is a short list. DHS Office for Interoperability and Compatibility, sitting all the way to the left. FCC, Public Safety Homeland Security Bureau, that's the FCC's focal point for what you do in the street. And we're happy to be part of that, sitting on the Emergency Responder Interoperability Committee, blah, blah, blah. Okay, it's the ERIC, and we're on the Public Safety Advisory Committee. And you'll see a slide about that. The International Association of Firefighters, that's us, the International Association of Fire Chiefs, and the Association of Public Safety Communications Officials. All of those folks are sort of the big names on the list that are concerned with this operability problem. Solutions. We know there needs to be improved audio standards for devices, and that's being worked on. Better operable system design and testing. How many of you have had your jurisdictions buy a whole radio system, install it, throw the switch to the right, and it doesn't work very well? A couple, okay. It happens. Improper testing or inadequate testing in the beginning is a real problem. Interoperability through comprehensive planning. At least 4 Ps there. That's where everyone says they want to be able to talk interoperably, but they haven't planned it all the way through. Knowing what channels, talk groups, zones, whatever your radios need to be programmed as to go from this jurisdiction to that jurisdiction, that needs to be planned ahead of time. You can't figure that out on your way there. Spectrum management. There's a lot of levels of government need to work out where the spectrum you're living in needs to be. Hardware training, we'll talk about that a little bit later. Know how to use the radio. Mayday SOPs. I can't emphasize enough. The radio has to work, and you have to know what you're doing when you try to talk. You're not going to have a lot of time to think back to what do I need to say if I have 30 seconds of transmission left? What do I need to say to get me out of a jam? What does everyone else need to do when they hear you talking for 30 seconds? Oh, this is the greatest thing since sliced bread right here. Public safety wireless broadband network. Does that look like that might have some failure points to it? There's at least 3 computers in this whole mess. And who knows what operating system they're on. There's just a lot of layers to this, firewalls and connections and interconnections and 4G radio access networks, and there's backhaul transmitters and all this other kind of stuff. Is this something that you need in the basement when you're through the floor? Maybe not so much. But that is where there's a whole movement to move towards because of space in the spectrum, which was created by the invention of digital television and the loss of analog television channels from channel 52 to 69 that went away. Now we have two chunks of the spectrum here in the 700s, the bottom half and the top half, and then the D block, which is the bottom half of this and the bottom half of that. The D block is that fuzzy little space of the spectrum that's in question as to whether the public safety folks will have access to it or not. I'm not going to spend a lot of time on that today, but that is where that digital broadband activity would happen. All of that D block public safety spectrum area that's in the 700s that they want to be digital broadband is coordinated by the Emergency Response Interoperability Center at the FCC. Underneath the ERIC is the Public Safety Advisory Committee, and we are part of that from the internationalist perspective. And within that, I sit on a tiny little committee that is the end user, that communicates the issues that you have back up through the chain. And that's the ERIC PSEC. And really, the bottom line is, at the last meeting that I went to, we're looking at developing the standards, the framework, the building blocks for that public safety wireless broadband network. They look at encryption, they look at security, they look at access. We looked at applications that might be helpful to you, and we looked at barriers to actual implementation. Congress is very interested in this. This is a very hot topic. Representative King has put House Bill 607 out there, Broadband for First Responders Act of 2011. Senator Rockefeller has put out S 911. Both of those bills are in Congress now dealing with the D block and that public safety spectrum. Not a lot is happening with it right now because we have some other issues at the federal level that they're dealing with. They'll get back to this eventually. In the middle of all of that activity on the Hill, they have had a number of hearings, including one that I was able to speak at. The House Committee on Communications Technology and the Internet, and we talked about establishing the public safety broadband network. Our message was very simple. Whatever you build, it has to be affordable, it has to be accessible, and it has to be operable. They keep saying interoperable, but it has to be operable. If I can't talk to you and you can't talk to me and I can't push one button to say help me, it's a neat gadget. It can go on the back of the BC's car, that's awesome, but it's not going to be in my pocket. To help the users out, a lot of folks got together and developed this voice radio communications guide for the fire service. Very valuable document. It takes you through the radio problem, the radio situation, from very basic to very advanced, all in one document, and that's available online, and the link is there. Is it all possible? Is it possible for us to have one very fancy nationwide interoperable system or system of systems that we can all talk to each other when we have to? Probably. Do we need to talk to the incident commander in LA from New York City on Tuesday afternoon at 3 o'clock? Maybe not so important. There may be a time for that in the future. If I can't talk to you in the basement, it's still a problem. Do I say, is it possible? I think it is, because on my hours off, I'm one of those ham radio geeks that has one of these little gadgets. This is my little multi-band two-way radio equipped with a GPS locator that encodes a little signal that says where I am, and I can talk to anywhere in the world with this for under $600. It's a worldwide standard. Well, worldwide groups of standards, so if volunteers can get together and agree on one set of protocols and one way to make this work, I have every confidence that it will work. Competition is important, cost of the devices is important, testing is important, but just remember public safety should put themselves in the buyer beware mode. If someone with a big yellow radio with a fancy letter on the front says, I've got 1,000 of these and I'll give you $10,000 off your first order if you buy now, and the chief buys them, is that the way to install an operable system? Not so much. How many of you have had that happen? Just curious to see. They got a great deal on a whole batch of radios and a system went in. Not so many. That's good. Very good. All right, this is my contact information. Happy to chat with anybody after the class. We're going to do questions towards the end. So if you could save your questions towards the end, that'd be great. All right, thank you.
We're the ones giving you technical comment.
Yeah. Okay.
Thank you, Jonathan. Jonathan kind of gave us a 50,000-foot overview of what's going on today. Mike Worrell is our next presenter. He's going to talk more about the different systems and how they affect us on the fire ground. Mike?
I got my one glove here to do Michael Jackson for you in a minute. This is a communications requirement from 1939 the FDNY wrote, and it says the department standards held the radio must be lightweight, compact, simple to operate, have a long operational life, be free in the operator's hands so you can do other things, communicate with other similar packs in an operation, be waterproof, dependable, have sufficient range to cover the fire area. That's a pretty good statement there. Does it apply today? Yeah, sure it does. What we're faced with today is, you feel like you're at Starbucks. I can barely go in there and order a caramel macchiato light, no whip. But when you start talking systems, you're talking about, I'll have a simulcasted digital trunk P25 Astro Smart Zone with TDMA, OTAR, and integrated voice and data. That's what you're faced with as guys out there trying to buy systems today. What this points out is the need for an in-house expert or a hired gun, a contractor or a consultant that's going to be your advocate. What's sad about this is I understand all those terms now. These are some obstacles to communication. We have the equipment itself, the ergonomics of the equipment, the environment we operate in, meaning the temperature and the humidity, the systems, the types of systems, design, technical details, and then there's also the buyer bewares. And then training, how we use the equipment, our organizational influences on, what we do on the fire ground, and then the behaviors of individual firefighters themselves. These are the radios that you look at over the years, mid-1980s to 2010. What's the difference between these radios that you notice? Size. Look at the knobs. They've tried to get bigger, but can you operate it with this glove on? Can you push those buttons that, for the face piece on this radio to change zones? Can you do that with these gloves on? No, you can't. So really, the manufacturers haven't made a radio that meets the fire service's needs. These are some of the environmental specifications. If you look at the environmental specs, like this one right here, all they do is they show the mil spec. They don't show any temperature ranges. When you look at this one over here, they list all the mil specs they meet, but then down here they list the temperature specs. and I think the highest one there is like 60 degrees C. They don't tell you the degrees in Fahrenheit. Why do you think that is? Because they don't want you to know. But 50 degrees C is 122 degrees. And let's see here, a little magic card here. So at 122 degrees, does that meet what we see in a house fire, inside a structure fire? No, it doesn't, because it's a little hotter than that. This is a test that was performed by NIST, and what they did was they actually tested, they tried to closely mimic what the fire service environment was inside a burning building. And what they found was, on the top here, they tested to 160 degrees C, which is about 320 degrees, and down here, they actually did a test up to like 230, which is about getting close to 500 degrees. But what they're finding at 160 degrees is, at 9.5 minutes, they didn't get any transmit or receive, and then at this radio right here, this B radio, there was a transmission signal shift, which means the frequency actually changed on the radio. The bad thing about these tests is they can test a radio like this, but then they can bring it outside, let it cool down, then it operates normally. So how often do you think in fires we may heat up that radio to the point where it's not working right, then they take it out, take it to the shop and test it, looks fine to us. So the problem is we need to get a radio that's built to meet our operating environment. So what do we buy? Conventional, repeated, trunk, digital, analog, I mean, you throw all these terms around, and then consider the cost. What you need to do is take into consideration what your operational requirements are, and you need to translate those into technical requirements so you can build a system that meets your needs. We built a trunk system in Phoenix, and we built a system, and we were expecting it to work the way we needed it to, and what we found was we did a bunch of testing inside the buildings, testing the digital trunk system versus our VHF analog system. And what we found was that the trunk system didn't actually meet our needs. And I found that, I could be 50 feet from a guy, and because I was in a area of bad coverage, I wasn't able to talk to that guy 50 feet from me. So what we did was we went back and we looked at what our requirements were. So these were our requirements. We wanted to provide immediately, predominantly local radio communications without changing channels, which is important because in a trunk system, if you lose coverage, you have to go to a Simplex channel to maintain coverage. We didn't want to have to have our guys change channels because we were afraid we'd lose them. And it has to support the tasks that are on the fire ground. And then crews operating in on air in contaminated atmosphere would be required to use Simplex radios. So Jonathan talked about Simplex, so I won't go into that, but basically, you maintain your communications by talking radio to radio. In the event you can't get out, you can relay using another person in the building. This is a duplex system, a repeated system. How many of you operated with repeaters? Okay. What's talk around? Anybody? Radio to radio. So you can flip a channel, you go to talk around. You're just bypassing the repeater. So when you go to talk around, you can talk to other people, but if they have to talk back to you, they're going to have to go to that talk around channel, which is different from a trunk system. A trunk system is a repeated system, but those frequency pairs that you're talking on are always switching, so there can't be a talk around. The only way you can have a talk around is go to a dedicated Simplex channel, which requires somebody on that fire ground to have to monitor that channel all the time. On the fire ground, where's the focal point of communications? Who do all the communications go through? Incident command. Where's incident command at? Right outside the door. Do you need to talk 50 miles away? No. That's a nice thing. The guy you need to talk to is incident command and the other crews that are on scene with you. Technological advances. Talk a little bit about digital radio, all the things there. And then trunk systems. Multiband radios. How many of you are using those in here right now? Just one. We're just starting to use those in Phoenix. Those provided a lot of flexibility because we operate on the trunk system for EMS calls where we're not breathing contaminated air. When we go into a fire call, we're using VHF analog, so that allows us to carry one radio and not have to carry two. Is this part of the communication system? Yeah. If you look on there's a voice port on those things, and the first part of the communication system is the brain, the way you process your information, the way you spit it out of your mouth, and then it goes to the voice port, then to the radio. This is from 2010, 2000, and then 2011. Look how much progress we've made in 11 years. Can you tell the difference? I can't. APCO P25. P25 is a term that's thrown around to give interoperability and do a bunch of wonderful things. P25 is actually just a language, a digital language for data transmission over RF. It was developed with public safety and manufacturers, and the idea was it was going to be a digital standard, and it was going to cause open competition on the market, provide compatibility so you didn't have to buy one manufacturer's thing, and it was supposed to drive the cost down. Are we seeing that? No. This is a vocoder. And this is where the problem with P25 lies. On this end right here, when you're speaking into a microphone, when you speak here, is there a bunch of noise on the fireground with you? Is your voice distorted coming out of that face mask? Well, when you speak into that microphone, it's picking up the distortion in your face mask, the background noise. What it does is it tries to take that and convert it to a digital signal, and it's taking your voice and all the junk behind it and converting it to a digital signal, which a bunch of that stuff you didn't want in there, and then it transmits it out. Well, when it comes back in and it's decoded, it's decoding all that information along with your voice, and it actually becomes unintelligible because of the background noise that was associated with your initial transmission. Karen will talk to you a little bit more about this. So, we look at NFPA 1981. NFPA 1981 is an SCBA standard. It's a standard for speaking through the mechanical voice diaphragm. And the average score is supposed to be about 80% intelligibility when you speak through that. And they have these hired listeners, and they sit them down, and they say words, and they mark down what they hear. Well, if they don't get 80%, it doesn't pass. One thing that was done a while back is they did that test with some digital radios. And this note right here is important. Use of the radio is not actually included in the test. It's just a voice test. And you can see the different type of face pieces and where the voice diaphragms are. But NIST, they actually went and they did a study where they included the radio in this process. And when they did that, what they found was that for vocoders, for P25 in two different types, one was 52%, one was 59% intelligibility, where the analog systems maintained the goal of 80%. So everybody that's on a digital system, they're fighting this problem with intelligibility on the fireground. This is a trunk system. When we look at these trunk systems, we need to make sure that they have the features that we need to support fire operations. So again, like we said, there's no fixed frequency, so what that necessitates is designation of a simplex channel, so that if there's not coverage in a building, you need to go to a simplex channel. There's complex design, so you need to have somebody that understands the design of the system. They can be designed in multi-zones, and each zone can have a different level of capacity, different coverage values as far as penetration for in-building. BDAs are things that they put inside the building that repeat the traffic in. The bad thing about BDAs is when we as firefighters go inside a building, what are we doing? We're squirting water, we're in a hot environment, we're tearing ceiling down. Well, BDAs, we can be actually tearing down the BDA on top of us because we're going in and doing those things. One thing that we looked at in Phoenix was vehicular repeaters, to be able to actually bring a repeater out on site that's mounted on the vehicle. That helps. And then digital, you need to think about, can you have analog channels within your system using an analog simplex channel instead of a digital channel? One of the big buyer bewares on this is the cost, both the initial, huge cost going in to get one of these systems, and then it's a big cost to stay on them because the software revisions that are required to keep up to date. When you look at these systems, how many of you are using Windows XP still? A couple of you. Windows 7, Windows Vista, all those different things. You have to keep up to keep the system up to date. So training, it's a system. The radio, the button knobs, beeps, bonks, Joe's going to talk about that. So we'll talk about the firefighter behaviors. These are some radios that we actually went into a fire that resulted in a mayday. When you look at these radios, do you see anything wrong with this picture right here? See that tape? That's athletic tape. The guy was taping it to his harness. Thought that'd be better. The bad thing was is he taped over his microphone port. So when he transmitted out of that radio, it wasn't working. So that's a training issue. The guys need to be really familiar with the radios, what those little holes are. I mean, that's the microphone hole there. If you get a piece of drywall or plaster in there, you know, it's probably not going to work. The other thing we need to think about is airtime, radio airtime. Finite resource. You only have 60 minutes in an hour, 3,600 seconds in an hour. So you need to use that time efficiently. So maintain some reserve. And what I mean by that is if the channel is completely saturated and there's no way you can get in, it's so busy, you know, what's going to happen if you have a mayday in the middle of there? You can't get in. So at some point you need to start thinking about breaking the incident up into different channels, you know, branching off, you know, those kinds of things. This is the way technology people measure their traffic, PTTs per hour, average message length. It's really not a good way to do public safety radio because these averages actually smooth those peaks out. So the systems need to be built for peak loading. So what does the future hold? Intrinsically safe. Karen will talk a little bit more about that. But what they're trying to do, or what they had proposed, was decreasing the power that the radios would transmit on, which would have a bad effect for us. We need to push for integrated communications in the SCBAs. You know, NASCAR guys, pilots, astronauts, scuba divers all have integrated communications. You know, we should have it. You know, look how long we've been around. And then fire service radios, radios that actually meet our needs. You know, big knobs, buttons, you know, things that you can operate with a glove. And the D block, again, Karen will talk about that. The big thing about D block is beware. And the other thing is this voice broadband radio. We need to be careful of that because, again, it'll be a digital radio system with probably small devices. You have some NIFOGs in front of you. This is a good deal. They've worked on this a long time. There's actually national interoperability frequencies in there. There's data on how to wire up phone cables, those kinds of things if you need them. And that becomes the value of these guys right here, this ICS. ICS provides us with a standard command system. Within there is a COM-L and a COM-T. These are all hazards classes that are coming out now, and they utilize this NIFOG a lot. One thing that's happened in the last 10 years is they've been statewide interoperability coordinators have been designated for each state. And these people work together to make sure that we have interoperability between the states, which is a good thing. The bad thing is the grant program that funded those people is gone now, so we'll see how long they stick around. The last thing is NECP goals. These goals, the Office of Emergency Communications required these to go around for grant funding. They required us to actually go out and perform and do interoperability at events, pre-planned events, which made us go out and practice what we were talking about, made us perform. So what is working? This is our unified command. You can see there at the little kiddie table, someone's getting ready to bring them their crayons and coloring books here in a minute, while the guys out in the field are working. But this right here, this is on the serious side, this is an MCT, or a mobile data terminal. 10 years ago, we didn't care what channel the police department was on. Today, you know, in Phoenix at least, we're getting the dispatch, and when we get that dispatch information, we get the police channel with it. So now I have a radio where I can actually talk directly to the police officer if I need him, which is a good thing. So again, this is the book, great reference book. Okay, here's my contact information.
Thank you, Mike. Again, if you would. Again, we'll hold questions to the end. Mike brought up a number of issues with Fireground voice communication, and Karen's office is doing quite a bit of work on these issues. We'll ask her to speak next on intrinsically safe and all the standards that she is working on to make sure that we end up with a product that works in the field.
Thanks. I'm going to talk about some of the technologies that we've been working on to solve some of these problems and some of the standards processes that we're looking to accelerate to deal with some of the digital problems that Mike has touched on. Just to give you an idea where my office is within Department of Homeland Security, Science and Technology, we have a group now that looks solely at first responder issues. And my boss is a previous fire chief, and so he understands your problems, and he's a good mechanism to start pushing some of your issues in the lovely bureaucracy of Washington, D.C. So one of the things I'm going to do is bring back to him some of the issues that I've discussed with him and I've been hearing in these meetings, so he can start pushing some of these issues in the LTE discussion, so he can start pushing some of these issues in the P25 discussions, so we can start dealing with the fire services issues. This is my office in particular. We're looking to get you the science and technology that will enable the emergency communications that you need, that will help you save lives and prevent loss of life of your colleagues. One thing I want to talk about on the NIFOG, I need to thank my colleagues in the Office for Emergency Communication. Yes, we've got OIC and OEC. We do that just to make sure everybody's completely confused about which office is which. Anyway, my colleagues work more on the policy end of things, and they supplied the booklets that you have there. They were kind enough to send them to me so I could distribute them to you. But my office actually started the first one. These are some of the programs that we're working on in my office. I'm only going to talk about the radio projects. In the package, what you'll be able to access on the website, you can go in and look at some of the other things. Because we're looking primarily at voice communications, I'm going to concentrate on the work that we're doing there. Mike touched on vocoders. When you change your analog signal, your voice, into a digital signal, there's a couple of things that happen. If you drop a few bits along the way, that usually doesn't mess things up as much. But what happens is if your signal gets a little out of sync, you get complete gibberish. There's no graceful degradation of your signal. It's gone. So one of the things that the fire service basically brought this to the attention of the Office for Interoperability and Compatibility, and we went to NIST, the Public Safety Communications Research Lab, and they've been doing some extensive tests on the vocoder performance to be able to quantify to the vendors who haven't necessarily been believing that this is a real issue. So kind of like putting Motorola in the fire, we've basically gone in and recorded, had actual firefighters come in from all around the country and do tests with the SCBA on, with the SCBA off, do intelligibility tests with background noise, without background noise, and have characterized that there's a huge problem. And they've identified some best practices that you can follow while we're also pressuring the manufacturers, the radio manufacturers, to deal with this problem. The best practices that we've recommended is that you take your radio microphone and hold it tight against the voice portion of your SCBA. We're also trying to get the manufacturers to do throat mics the in-mask mics. Also, a number of manufacturers, since we've identified this problem, have come up with noise-canceling microphones, so it cuts out the background noise and only picks up your voice. The other thing that they've done is in the P25 process, which I'll speak to in a little bit, they've updated the standards so when the alarm, your low air alarm goes off, the microphone will cancel that noise out so you can still hear your voice over that alarm that's going off in the background. That's the one thing that P25 has already adopted, and we continue to work this vocoder, these vocoder results into the P25 process to try to get the manufacturers, to try to force the manufacturers to address these problems. Speaking of P25, I know you've seen a lot of complicated systems, diagrams, and everything like that. And when I first came onto this job, everybody was talking about CAI, ISSI, FSSI, and I'm just going like, this is alphabet soup. I need a map. Well, I'm sharing my map. This shows you basically where all of the interfaces are. And I want to point out in particular the ISSI, the RF subsystem interface. That's the one P25 standard out of 8 that is complete after 21 years of deliberation. It's old enough to drink. We are working to accelerate these standards, and there's a couple of ways we've been doing this in the last year or two. The first way is we're trying to strengthen the user needs group, the group that goes in and says, here's the priorities for us. And Paul is on that group and shares my frustration with the P25 process itself. So what we want to try to do is make sure that the user needs are heard and that we're gathering and explaining to the manufacturers what you all need. And then on the other end of the equation, these actually standards that are now highlighted are the standards that the users have identified as the important ones. Some of those standards are important to be able to operate, to communicate with your own group and with your adjacent localities group. But some of them also are important from a competition standpoint, in particular the console interface. If you can have that standard in place, then you might not have to be stuck buying a certain infrastructure, one vendor's infrastructure and their consoles. You can buy a smaller vendor's console at a cheaper price. It forces competition in the market, and I know I'm going to slip up and start calling out the vendors. I'll try not to since we're on video. So one of the other ways we're looking to accelerate the standards is working with our NIST colleagues and our Department of Justice colleagues to try to reinvigorate the P25 process. We're looking at, like I said before, getting the users involved and making sure that their statement of requirements are addressed by the P25 in TIA, which is the industrial association that sets these standards. The other end of the spectrum is the compliance assessment process. What we were finding is vendors would say they were P25, and then you would buy a certain vendor's equipment, and then buy another, you would buy a certain vendor's infrastructure. Okay, I'll call them out. You buy Motorola, and then, so you've got a Motorola infrastructure, and you go out and you buy Harris units, handheld units, and they don't work together because one of those or both of those manufacturers have built in proprietary things into something that's supposed to be a standard. When we were finding out about this, Congress heard about it and basically said enough of that. And so what we've set up is a compliance assessment process, which enables independent verification that people meet the P25 standards. And what we've done now to take it a step further is we've removed this from some of the bureaucracy that's associated with the P25 standards process. We had hit a we had hit a jam getting a conformance test on the handset. So the vendors didn't want to do it. So what we have done is we've taken it out of the P25 process. We are writing our own conformance tests, and we're going to use this, bringing the compliance process out to ensure that these manufacturers really are developing equipment that's able to operate with other vendors' equipment. And the last thing I'm going to talk about with radios is our multiband radio work. Paul has worked on it, and Mike has worked on some of our pilots. The multiband radio grew out of a Department of Defense program, and what it enables you to do is you can work in you can use one radio and work in different radio bands, and up to 5 different radio bands. There is one manufacturer, I won't call them out this time, that claims that they have a multiband radio, but it's actually a dual band radio. And right now, there are actually 2 multiband radios on the market that we're testing. And there's a third manufacturer that's coming out that claims that they're going to be able to deliver it at like $2,000 a handset less than what the multiband radios are on the market right now. So right now, most of the multibands are about $5,000 a handset. They're looking at the $2,000 to $3,000 price point. And what we've done with this project is we kind of spurred the market. We got the one manufacturer that was able to deliver it, and then the other manufacturer is coming on. So it's creating a marketplace to enable you all to not have to cache as many radios, where you can go into the next jurisdiction, and if they're operating on a different frequency, you can dial into that frequency. Now, is every fire person going to have a multiband radio? Probably not, but your system commander might. And so, again, going to design your system properly, this is another tool in your toolbox that you can use to help you operate and interoperate on the fire ground. So with that, I'm going to pass it on. The rest of the slides in this presentation go into data standards and things like that, video. I welcome you to take a look at them, and if you have questions, please feel free to contact me.
Thank you. Thank you. Now, Joe is going to walk us through some very important stuff that we can do on the firefighter level. We've talked about the 50,000-foot level. We've talked about systems, some of the opportunities and problems, what the feds are doing to help us out. And Joe's going to give us some really direct, good information on what we can do in the firehouse and at the department level to improve the safety of our users who are using this equipment. Joe.
Morning. Basically, I want to speak to the issues of ground, what you're carrying today, why they're not working. The International will tell you that the flow of information between firefighters and fire officers is imperative to fire ground safety. NIMS will tell you that radio is used to paint the picture for incident command. My COML instructor would say, no comms, no battle. And that's what it comes down to. If you can't talk, you can't do your job, you can't stay safe. The three issues are training, planning, and troubleshooting. Do all of NIST, they investigate every fatality. Time and time again, they point to a lack of communications or a failure of communications that leads to fatality. And here they'll tell you that you receive hundreds of hours of training on everything that you do, but not a lot on radio communications. Is that better? I didn't put it in. Anyways, you train on half valves, you train on RIT, confined space. How many times does it involve the radio component of those evolutions? Make sure that that's part of it. Recently, it came to light in Columbus, Ohio, how important it is, radio discipline. Think about what happens on the fire ground when you hear something like this. That firefighter's world went right downhill, okay? All of that radio discipline, all that radio training now comes into play. Luckily, I can tell you, he bailed out a second floor window with minor burns. The building flashed, they lost their water supply, and now he was in a Mayday situation. Radio discipline couldn't be any more important for that man. Now, I also will tell you that firefighters don't know how to use the radio in general. They're very complicated. There's hundreds of options. How to use the radio while you're with the SCBA, and what you do during a Mayday. Most of you are not to use the radio during a Mayday. Typical radio that you're going to see in the firehouse, you are not going to be bringing an LTE device into the fire ground. The radio that's sitting here, or something like it, is what you will finish your career with. You have to make the radio work for you. It needs to be customized to how you do your job. Some of the features that people use, we use these in Boston. Mirrored channel stops. The first and last position on the dial that clicks is your primary channel. You work in an environment where you can't see the radio, it's in a pocket, you just have that little knob on top of the microphone. The emergency alert button, everybody should be using that. It tells dispatchers right away who is in trouble. Something that we do, repeat channel gets a side tone, so when you key up the radio, you hear a tone, you know that you're on a channel where there's a dispatcher. If you key your radio up and you don't hear the side tone, you've gone to a direct channel. You can't talk to dispatch on a direct channel. So there's just a little tip-off that makes it easier for the firefighter. We use a feature called auto scan. It wasn't until that we had a rescue in one of our tunnels, the firefighters had gone 1,000 feet down into a plenum and were beyond the coverage of the system. At a safety committee meeting, they raised the question, what happens if we push the Mayday button? The answer is nothing happens. Nobody hears it. Going back to the software, we find out that by using auto scan and programming the radios to constantly scan the input frequency, now when we send 5 firefighters down a tunnel, one firefighter hits Mayday, the other radios go into alarm because they're scanning that input signal. We do this system-wide. Firefighters operating in a basement on a repeat channel, they lose coverage of the repeater. The firefighters don't even know. They don't have to start searching for direct because all the radios are scanning the input. If they don't hear the signal on the repeater, they just listen to it on the input. It's transparent to the firefighters. You need to make your radios work for you. Minimum volume. Sounds basic, but it's important. Make sure you can't turn the radio down so that you can't hear it. Keypad lock. There's too many buttons on the damn radio. Make sure you've got a feature where you can lock those buttons out. Call sign decode. When somebody's talking, sometimes incident command can't make him out, but if he looks at his radio, he can see the call sign. We have 1,700 call signs programmed in every radio. So when you hit the Mayday button, we can see on the radio who it is that hit the button. Not just relying back at dispatch to give you the call sign, but every radio on the fire ground will go into alarm and display the call sign of the person that hit the Mayday. Call alert. Command says, ladder 7 roof, we can't find them. Now dispatch has a procedure, they put that radio in alarm remotely. So we can tell the incident commander, the radio's on channel 2, it acknowledged the alarm, and it's sounding an audible signal that you can look for. EEB alarm and decode, I just mentioned that. You hit the mayday, everybody else working with you gets the alarm and knows, stand by and listen. Disable and stun. Make sure that if you lose a radio, dispatch can kill it. If you're operating on a Simplex channel, those alert tones that you're used to from dispatch don't exist. Make sure if you have that feature in the radio, turn it on so the command can generate that evacuation signal at the incident. The emergency alert button, it's not as simple as just push the button and help will come. Make sure the firefighters know what it sounds like when the radio system acknowledges that mayday. The radio will tell you, yes, dispatch knows you're in trouble. Or, dispatch didn't hear a damn thing. The radio will indicate that it's trying again and again to get that signal out. If you're in Boston, but you somehow ended up on the Wakefield channel, a city 15 miles away, nobody's going to hear it if the radio's in Boston. Okay, make sure the firefighter knows what the radio's trying to tell them. When you do hit the orange button, make sure it stays in alarm. It generates an audible beacon so that people searching for you can listen to the sound. Turn on the remote monitor function if you have it, so that dispatch can open up your transmitter and listen to what's going on around you if you can't talk back to them. Make sure firefighters understand what revert is, so that if you're operating on a direct channel and you hit the orange button, it's going to change channels so that it can send a signal out to dispatch. If you clear it, then you change channels back to where you came from. People need to know how all that plays out. You need to develop a field operations guide for your radio system. We have about 20 or 30 chapters, and we make it part of the monthly training. The headquarters sends out a list of training topics. It's always a communications guide that's in there and says it's chapter 10 this month or whatever it is. Document everything in the system, okay? Training has to be ongoing every month. Include dispatchers in your training. Take them out, show them your world so they understand what's going on when you're not answering the radio because you're charging a line, or why you can't change channels at that particular time and you'll get to it. Okay, but they need to know your language and see what you're doing. Make sure everybody knows the channel plan. This is what we have. It's 400-something channels, barely enough. But we use our CAD system and our dispatchers to make sure the firefighters know what zone and position to be in. We have 35 cities and towns in our mutual aid district. If our companies leave town, we tell them what zone and position for that local primary channel. There's a firefighter in New York carrying 3 radios, and he's got the channel plan hanging off the radio. Okay? However good your system is, if you've got the top-of-the-line system, do not get a false sense of security because you've got a great radio. The radio's going to last a lot longer than you. We had 2 firefighters that were lost in this Chinese food restaurant when the fire flashed. This is the radio that was in the fire coat, and after 45 seconds of direct flame, while in the fire coat pocket, the microphone cord melted through and triggered the emergency alert signal. That was the first indication that dispatch had something had gone wrong. Planning. You build a nice big system, but now did you talk about radio coverage in buildings? These are privately owned properties that need to provide radio coverage for you. You have to plan for these things. This year in Columbus, Ohio, all of a sudden they were surprised that their brand new fancy courthouse had no radio coverage whatsoever. It should never get to the point where the building is built and then somebody figures out that the radios didn't work. We did a survey, figured out nothing worked. What a surprise. Who would have thought a building full of concrete and steel and covered in glass that blocked radio signal would have a problem? They had to postpone the opening of the building, go back, do a survey, install a new system, and again they found out it was the glass. Years ago in a high-rise, the radio thought of that building as Swiss cheese. Every window was an opening for the radio signals. Now every window is blocking the radio signals. We used to teach firefighters, go to the window so your radio will work better. Now it's go to the window, break it, and your radio will work better. You can't always break the window, but that's the principle. Luckily in Massachusetts we have a strong building code, and we can mandate the installation of a bidirectional amplifier so that we have 95% coverage throughout the building specified to our signal levels. And we don't have to modify our system to make the building work. This year, the International Building Code, for the first time, put in those standards that the state has adopted. So after 2 months, they reopened the courthouse at almost $500,000 to put it in the system. It would probably be under 200 or 150,000 to do it while it's under construction. But this building was finished. You can imagine all the cables had to be run through finished ceilings and walls. So you have to do planning. Troubleshooting. The portable radio is always going to be the biggest point of failure in the radio system. Batteries. You got to keep the contacts clean on the battery, clean the contacts on the radio, and make sure that you buy new batteries. This one here was born, you can see that 3-digit number 605. So it was born in the 5th week of 2006. That means that battery is trash. Make sure all the firefighters check their batteries every day. Check how old that battery is. You got to keep them clean and maintained. I found both of these in firehouses as I was there updating the software. Underneath the plaster is an emergency alert button. That's another antenna that they were happy to use. Firefighters also believe that you don't need antennas for radios. You got to have an antenna, and it's got to be screwed in nice and tight. Got to maintain these every day when you come to work, shift change, check the radio. We talked about software earlier. Typical XCS 5000 purchased in 2005 came with software version 7. Today they're up to 16. There were literally dozens of upgrades to errors in the programming that have been made. There are some new features, like the pass device filter for the P25 radios, but you have to make sure that your radio has the current software in it. Some resources for you. The International's Fireground Survival Program has a great couple chapters on communications, especially Mayday comms. We've talked about the Voice Communications Guide, another great resource. And if you're interested in in-building specifications, you can see ours at bfdradio.net. And if you click on the International logo, you'll get this PowerPoint as well. Thank you.
You can see the technical side of these systems is very complex. So we used a little training video in Phoenix, and we'll share a short portion of it with you to hopefully with a little humor demonstrate how the systems work. If I can get it to put up there.
Okay. All right, here's the unit Gary just brought in. We'll go over a few of the things with this. Basically, this is the main meat and potatoes of the unit. This is the operating part of it. You'll see a lot of different controls here, and I'm not certain what they all are, but some of them are volume control, squelch control, and then some way of programming this in. And they'll get to that educational part of that. You'll notice an antenna here. One of the things that they also are working on is shortening that antenna somewhat so you got a little more clearance.
You can shorten the guide too, Jace.
Yeah, that's true. You could have a shorter radio man than what Gary is. On this side, you'll see what looks like just regular car battery cables, but what in actuality what they are is an ability, if this unit does lose power through the batteries, it's the internal batteries, you'll be able to, the idea was to get to a vehicle or a car?
Yeah, they say that I should probably carry a Halligan, and what I could do is actually commandeer a vehicle and plug into it and get juice back.
Yeah, so that's what that's for. You know, and I know you guys are looking at a lot of this, and this is crazy and insane, but, you know, once we started working with it, it was pretty user-friendly, wasn't it?
I thought it was very user-friendly. I enjoyed working with it.
Well, here you'll see they've attached a glow stick. It's just for identification that this is the radio man or radio person coming in, and it's just another added feature of safety. Also on this side in the pouch, you have what looks like one of the old brick phones, but in actuality what this is capable of doing, if you need to send a crew member forward away from your location, maybe upstairs, somewhere else, you can just deploy this to the crew member and he'll be able to contact back to you with using this. So it's a nice feature that's in here. Your speakers does a couple things. The radio person will have earphones on, he'll hear all the transmissions. But one of the nice things is just operating around this unit, we'll be able to hear any of the transmissions coming or going. So there's a nice added feature that Leif and those guys thought about, and I know they've traveled around the country looking at all the things. What you see here is a compile of all of the issues with 800 megahertz across the nation, and this is the unit itself that they've come up with. In this pouch, you'll see another radio here. It has a mic that hangs over the main unit. It comes back down like this, and this will be able to contact different agencies. Once we all get on the 800 megahertz network, this will be able to contact all of your S agencies like DPS, APS, GPS, any of those kinds of things you'll be able to contact through this. Also, hospitals. We actually, the other day, messed around. I don't think it was intentional. We got a hold of
Pat Grimes over feedback on his trucking business. He's doing fine. He wanted everyone to know. And you talked to some of our service soldiers over in Afghanistan.
Yeah, it was. I don't think it was intended for that, but that just shows you the
power it's got.
The power that this thing has. We were able to get some of that. And I think Leif and the guys are working on some of those issues of a bleed over. So basically, that's what you're seeing on the back end of this unit. And what do you think this weighs, Gary?
Well over 100 pounds. I'm getting pretty tired right now.
Yeah. So
it's heavy, Jace.
Is it? Well, that's something else that technology will address at some point. So with this, we'll go ahead and, Gary, why don't you turn around for a second? And this is where the rubber meets the road. This is where the operating part of this unit is. And you'll notice here that there's a lot of mics across a bandolero style holder here. And basically, you know, and it is true what Gary said. It's a shorter guy in the back would be able to reach those knobs if he was a shorter radio man. But a guy using this like Gary, if you notice, he's got a natural shelf here that will display these radios. So if you've got a guy that can eat quite a bit, you've got these radios right presentable for you. So
yeah, I think my stomach helps hold them up so I can see.
Exactly.
One thing you gotta let everyone know, you always start with your left hand. This will always be the command mic.
That's right.
As you work across, all the way to this far one is Lark.
That's it.
So in between, and I don't know all of them yet, I'm still learning them. These are sectors, and it goes on. Rub your hands and come across, and you'll feel them. You don't even have to look. You can touch them.
So in a smoke-filled environment, you don't need this
I
eyesight.
won't go in a fire, Jace.
Well,
the radio guy will never, this can only take 300 degrees.
I see. So what is the communication challenge then once the crew goes inside? What's the system?
I have what they call a wire wheel back here. You didn't see it. It's hidden.
Mm-hmm.
I can hook you up to a portable mic. You can go into over 300 feet with this thing, and you won't have a problem. Now, that cord's rated for 5,000 degrees, so you don't have nothing to worry about.
See, and that's the kind of thought that Leif and the guys have put into this.
So there's so much thought. Just playing with it that week, I just enjoyed it.
Exactly.
Thoroughly. You just got to work
See,
your way across.
basically, I think command, so you always, with the left hand, go to your right side, and that'll be command, that'll be your tactical channel, and then it'll come down to emergency traffic, maydays, and so on, right on down. If you had a really bad situation, you have the capability or possibility of all of your crew members coming up right into this area here and being able to talk, all four guys will be able to talk right here.
It's a quick release. If you notice, if you take two hands, pull it. Always replace it to the, they're going to number both of these because it'll get confusing for some people. Yeah. I haven't had too many problems.
Yeah. So at this point, I want to show you, we're going to go ahead and activate and key this up. At all times, you need to, there was some concern about the vitreous humor in your eyeball being affected by a lot of the gamma and alpha mega rays. So before I key this up, you need to constantly have safety glasses on whenever operating this thing. And one of the other ideas here too is that if I'm in an interior position, well, the union's going to appreciate this a lot because we actually need to get a fifth man.
It'll take another man.
And
you're forgetting something else, the radio person, not radio man, remember? We need to find, he can carry the tick for the captain, and I brought a tick along in case you want to see how that works out with the radio person.
That's good, and we'll show how the tick operates. But basically, as a company officer in an interior position, what I would say is for the radio man to come forward. He needs to be near my side at all times. And I'll just demonstrate the command mic here. If you can't get it unclipped, that's okay, because you can still get right into this area. And then just, I'm going to go ahead and depress it. Wow, that took some of the lighting out of the building. I don't know if that's
a lot of power
a
in these,
technical.
JC. A lot of power.
So I depress this, and I'll talk into this area here like this, and I'm constantly with the radio man. You
The
should
radio man can help him too by holding his balance.
I know a lot of you guys are wondering how this all works in correlation. There's a lot of tasks being put on us. We also have the thermal imaging camera, and we want to get that out of the company's officer's hand.
You get the idea. So, you know, it gives a good demonstration of, you know, how some people fear the complexity of the technology, and it is complex. And before we open it up for questions, we just wanted to make sure that we left you with a few thoughts. Is, you know, a lot of folks, particularly firefighters, you know, don't ever want to use a Mayday. Of course, we don't ever want to be in that situation, but if we are, we want to make sure that the members are fully confident through training and through usage that they know what to do and how to act accordingly with their equipment. So training is enormously important. I think it's been mentioned, buyer beware when you go into these systems. These systems have an enormous cost, and not just an upfront cost, but an ongoing cost. They can be budget eaters. So it's very important for you to have advocates for your side, whether you have in-house expertise, as we have in Phoenix with Mike, or the fire department hires its own consultant to represent your needs and your issues in the ongoing discussions of system design and usage. Buy gear that supports your operation. So many vendors will try to go in and say, we've got the greatest thing since sliced bread, and by the way, here's the way you need to change your operation to support our technology, when what we need is absolutely the opposite. We all also need to, on the local, state, and federal level, talk to our political leadership about what we need. We've heard about LTE and D-Block and APCO and all of these systems that don't necessarily support voice communications on the fire ground. And that is our issue for both operations and firefighter safety, is we need good, dependable, safe voice fire ground communications. Many federal politicians in particular seem to be addicted to the term interoperability. I don't need so much to talk to the federal agent in charge in Fargo, North Dakota, as I need to talk to my crew and my fire ground commander. And we need to keep pushing that political message on all levels. Thank you for your participation today, and we will open it up for questions to our panelists, and please use the microphone in the middle.
Hi, good day. Dave Burry, St. John's, Canada, Local 1075. I want to say I appreciate your presentation and the issues with respect to, you know, digital multiband communications and software. What I'm interested in is how much work or how much has the industry done and the standards done to simplify radio communications for firefighters. Basically, I need three things. I need a frequency, I need volume, and I need an emergency activation. You know, I need buttons or controls that are easy to access, readily identifiable, and easy to use. And you know, up through the years, I haven't seen the radios that still have these little small controls that you can't really see, et cetera, et cetera. I'm just wondering what's being done with respect to that. What standards are we putting in place to enforce that manufacturers supply these very basic you know, tools to firefighters who need them? Thank you.
Thank you. And I believe those are the common questions that we're all working on and that we're all concerned with. Everything from simplicity of the actual system to simplicity of the device that we hold in our hand. And that goes back to what I just talked about. We all have to, on the local level, you know, insist when we're working on these contracts that we have pieces of equipment that are usable for us. It's also dependent and imperative for our federal partners, which is what Mrs. Ray talked about in her standard setting stuff that she's working on, is to put pressure on the vendors and the standard setters as well to come up with those solutions. We're certainly not all the way there today. We're all going to have to keep pushing and pressing, but Karen, do you want to address a little bit of what you're working on there?
Yeah, most of the standards that I talked about were really what enables your system to talk back and forth, but I will be taking back, you know, simplify the handsets to the folks. And just one thing that I can't understate here is that the power of your voice is actually quite important. I didn't talk about the intrinsically safe issue. It came to my attention and I brought it up to the National Public Safety Telecommunications folks and to the P25 folks. And we had some of your users, and in fact, one of the fire chiefs from Chicago had Factory Mutual. I felt sorry for the Factory Mutual folks for a while there. What happened is Factory Mutual and United Laboratories decided that they were going to adopt an intrinsically safe standard that would cause you to have a radio that was 1/10 as powerful as your current handsets. Now just think about how many more guys that you would need to do direct mode. Just think about how many more towers and how much more infrastructure you would have to build if your batteries were 1/10 as powerful. So the Chicago fire chief was really convincing, and it was going at the Factory Mutual guy. Okay, you mean to say I'm going to have to put 10 more guys in danger because you decided to arbitrarily adopt this standard? I mean, he was great. And what's happened, good news, is that the pressure that the NIPSTIC and SafeCom users have put on the United Laboratories, OSHA, and Factory Mutual, they are going to, they're adopting a waiver now on intrinsically safe for land mobile radio. So your voices are heard, it is really effective, but you do have to, you have to keep it up. And it sometimes you don't see the results, it's not as apparent, but you are getting your voice heard. I'm certainly going to take this back to my boss so he can start fighting the bureaucracy battle in Washington, D.C., but keep it up. I was really surprised that we got as far as we did against the United Laboratory and Factory Mutual bureaucracy, so it does work.
Jonathan, do you want to add to that and anything you're doing in your committee?
Just very, very briefly, from a practical perspective, it goes back to the question, how are they going to know that these radios or these buttons don't work with gloves on? And I can say from where I sit on the Public Safety Advisory Committee for ERIC, that anytime anyone brings up any kind of a device that's meant to be used on or near the fire ground, I always bring up the point as simply as I can. I want to be able to use it when I'm on fire. And, you know, I can spell that out as basically as I possibly can with them, is I want to be able to take this thing with this gloved hand and make it tell somebody that I'm in trouble and distill it down to that. And the rest of us at the International, same thing. The health and safety folks, whatever device you come up with, because no one's come up with a device yet, it has to be big knobs, big screen, easy to use, doesn't melt, all those kinds of things. So the message is going back every time at the level that we're at.
Mike?
Yeah, one other thing too is, again, you need to find a guy like Joe that knows the radio inside and out so that you can program the features in the radio that are available today so that the radio works for you, because those radios can do a lot of things, and depending on how you program them, can make them practical or impractical for the guy out on the street.
Next.
From St. Louis County, we're currently in the process of an 8-county implementation of a system that's 2 counties on the Illinois side, the rest with the city of St. Louis and the surrounding counties. With St. Louis County, where I'm from, we're kind of the hub of that. This is a $100 million system. We did everything, we're doing everything that you spoke about getting an expert on board. We've got hired worldwide consultant, a consultant that's even operated in Dubai and in several big Washington area systems have been put in play. I was terribly disappointed that we were headed in this direction, and that when we created this RFP with about 780 bullet points, technical scoring points, and they only were going to allocate about 15 or 18 of these to true functionality for firefighters in the street. So what we did is we created a user group and really demanded of this consulting firm to put us in front of all these walkie-talkies. They had to come in and create their two systems. They had to be interoperable with their two systems. And I'm telling you, folks, you better start doing some of this. We were told that nobody else in the country has ever done this before negotiating with a company to purchase a $100 million product. I couldn't believe it. But what we did find out, I will tell you this, probably, and there was about 26 very specific tests that we did. I'm sure it's the same stuff you guys are doing. But there was only really 2 walkie-talkies that met our standards. I mean, at least 50% of the walkie-talkies tested with any type of noise issues, you couldn't even use them. So just beware, that's all I'm saying, and keep up doing the good work, guys.
Thank you, and that's a very good point for everybody to take home is it's difficult for us as firefighters, being the minority user, you might say, in the system compared to the thousands of police officers and streets and water and wastewater and parks users, to get the policymakers and the decision makers to come around to where they recognize our needs that we need for safe operations. So you do have to keep pushing like that. That's the only thing I can tell you is keep on fighting that fight, and maybe a good offline discussion for you and Mike and Joe as well, who have been intimately involved in those specific technical issues to make sure that things work for us. Do we have any other questions today? Any comments from our panelists before we close? Thank you very much for your participation. I know the IFF will want you to fill out your forms there on the table.